Welcome back to section 912. We're still talking about the graphs of polynomials. We're going to see a lot of repeats from the last section, so we're going to keep reviewing that concept. Once again, the roots, the zeros, the solutions, the values of x that make y equal to 0. Those are the x-intercepts. The maximum number of roots. The maximum number of roots, the maximum number of solutions is the same as the degree. And now the turning points. The number of times that this graph is going to turn, it's the degree minus 1. So we can use what we talked about before with our multiplicity, the turning points, and the end behavior. So we can make a quick sketch and we can list the zeros. So our degree, we can add up the x's. 1, 2, 3 x's, so the degree is 3. That is odd. And the leading coefficient is 1, which is positive. So our graph is going to look like this. So for the number of turning points, the max turning points is 3 minus 1, which is 2. And now the x-intercepts, the zeros. -10, 0, -7, 0, and 12, 0. So with that, we can make a quick sketch. Here's my -10, here's my -7, and here is my 12. So it's going to start and go up, turn, go back down, and then I'm going to move my 12 just because I messed up. I'm going to put it there, and that's a basic shape of the graph. So the degree was 3. There's 3 x-intercepts, 3 solutions, 2 turning points. For number 2, the degree, count up the x's. There's 4 of them. 4 is even. Leading coefficient is a positive 1. So for the turning points, 4 minus 1 is 3. Now our x-intercepts, the zeros, -6, 0, -3, 0, 5, 0, and 8, 0. Here's my -6, my -3, my +5, and +8. So it's going to have this basic shape to it where it opens, rises left, and rises to the right. So it's going to start here, go down through, back up, through, down through, and then up through. There's a quick sketch of our graph. Number 4, our degree. 1, 2, 3, 4 x's, so the degree is 4, which is even. And the leading coefficient is a -1, so it's negative. So the shape is going to be like this. So for the turning points, 4 minus 1 is 3. And now our x-intercepts, -4, 0, -2, 0, 6, 0, and 10, 0. So here's my -4, my -2, my +6, and my +10. Now, it's going to start, it's going to go up through, back down through, turn, back up, turn, and then back down. And there is our graph. And for number 4, our degree. Now this first one is 2 x's and then another 2 x's, so it's a degree of 4, which is even. Our leading coefficient is a +1, so the shape, based on the end behavior, is going to look like that. And there's going to be, for the turns, 4 minus 1, which is 3. And now the x-intercepts, -7, 0, and +7, 0. Now they're both repeated twice. They have a multiplicity of 2, which means at those points they're going to bounce. So here's my -7, and here's my +7. So in order for it to have this shape, what's going to happen, it's going to start up, and it's going to bounce at the -7, go back up, turn down, bounce at the +7, and go back up. And that's a quick sketch of our graph. So just a repeat of what we talked about in the last section. Another example, problem number 5. Our degree, we count up the x's, none of them are repeated, so our degree is 5, which is odd. And the leading coefficient is a 1, which is positive. So the shape, like that. That's the end behavior. Now for the turns, it's 5 minus 1. So it's going to turn 4 times. And our x-intercepts, -6, 0, -3, 0, 5, 0, 8, 0, and 12, 0. So here's our -6, our -3, our 5, our 8, and our 12. None of them are being repeated. So you're going to see it's going to start and it's going to go up through -6, back down through -3, turn, go back up through 5, turn, down through 8, back up through 12. And you can see 1 turning point, 2 turning point, 3 turning point, 4 turning points. There's our graph, our rough sketch. And then number 6, the degree, 1. This x counts as 3, so that's 4 total, and 5. Our degree is 5. And our leading coefficient is a -1. So that's negative, so it's odd, and negative, so it's going to have a shape that looks like this for the end behavior. Now for the turns, 5 minus 1 is 4. So that's the maximum. There's not going to be exactly 4 turns always, but that's the most we can have. In fact, we're going to have a few less because of the repeats. So our x-intercepts are at 0, 0. Don't forget that first one. -3, 0, and that one's 3 times. And then 5, 0. 0, 0, we got our -3 and our +5. So what's going to happen to have this shape? It's going to go down through. Now when a multiplicity is 3, when it's odd, it's actually going to go back through again. And then it's going to turn and go back down again. So that's the basic shape of our graph. Now, we can use this graph to actually write the equation. If we're looking at problem number 7, because of the end behavior, I can see there's 3 x-intercepts. There's no bouncing, so I know my degree will be 3. And I know my leading coefficient is going to be a positive. Now I'm going to make my leading coefficient for these a +1 or a 1. So now I know my zeros. My zeros are at -3. Let me write it differently. X equals -3, x equals a -1, and x equals a +4. So when we do this, we're always going to subtract our zeros from x. So it's going to be x minus -3, x minus -1, and x minus 4. This is how we're going to write our polynomials. So x minus -3 is actually x plus 3, x plus 1, and x minus 4. When we multiply more than 2 polynomials, well, you know what? We'll leave it just like this in that factored form. That's actually a nice way to write it. F of x equals, and we'll leave it just like that. Later on, we'll talk about multiplying these polynomials. Number 8, looking at this, I can see, based on the turning points, it turns once, twice, 3 times, and also there's intercepts. So the degree is going to be 4. It's going to be even for sure. And our leading coefficient, because it's going down like this, is going to be a negative. I'm going to make it a -1. And my zeros, I see one at -5, so x equals -5. x equals 0, and x equals 2. Now, because at the 0, it's bouncing, that counts as 2. That's repeated. So we write this polynomial, f of x equals x minus negative 5, x minus 0. And because it's repeated, we're going to square it. And then x minus 2. So f of x equals, it's going to be x plus 5, x squared, and then x minus 2. And you'll commonly see this written as f of x equals x plus 5. X squared would be written first, then x plus 5, and then x minus 2. Order doesn't matter for multiplication, but you'll commonly see that single monomial at the front. Let's do another one. Now we can see this turns 3 times. Because it turns 3 times, to find the degree, you would add 1 to the turns. So the degree is 4. And because it's going like this, where they're rising left and rising right, the leading coefficient is going to be a positive 1. Oh, I messed up on problem number 8. That should be a negative out front. Negative x squared, x plus 5, x minus 2. Almost missed that. And then our zeros for number 9. X equals negative 1, positive 1, and then x equals 4. So I see at the 1 it's bouncing. So that x equals 1 is repeated twice. So our function f of x equals x minus negative 1, x minus 1, and that's going to be squared because it's repeated, and then x minus 4. So when we clean that up, f of x equals x plus 1, x minus 1 squared, and then x minus 4 would be our polynomial in that factored form. And then for the last one, number 10 here, looking at it turning 1, 2, 3 times, the degree, we would add 1 to that. So the degree would be 3 plus 1, which is 4. And the leading coefficient, because it's falling left and falling right, is a negative 1. Our zeros are at negative 3. Oh, that's a 2, excuse me. Negative 2. X equals negative 1, x equals positive 1, and x equals a positive 2. None of them are being repeated. I don't see any bounces. So f of x equals x minus negative 2, x minus negative 1, x minus 1, and x minus 2. So it's going to be x plus 2, x plus 1, x minus 1, and x minus 2. And there's our polynomial in that factored form. Now I'm going to do some further examples of our graphing. So if you want to stick around, you can see that. Otherwise, you can go to the next video. So here's some more making a sketch. You can see our degree. Count the x's 1, 2, 3. Leading coefficient is a negative 1, so it's negative. So it's odd and negative. It's going to have a shape that looks like this. Now our zeros, or x-intercepts, would be at 0, 0, negative 1, 0, and 3, 0. So here's my negative 1, my 0, and my 3. So the shape, it's going to go down through negative 1, bounce, go back up through 0, 0, turn, go back down through. There's our sketch. For number 12, count up the x's. This is 2, 3, 4. So our degree is 4. Our leading coefficient is positive, so it's even. and positive, so it's going to have a shape that looks like this. Now our x-intercepts, 1, 0, negative 2, 0, and positive 4, 0. The first one is repeated twice because of that squared. So I have my negative 2 here, my positive 1, and my positive 4. So now it's going to bounce at 1. So to have that shape, it's going to go down through the negative 2, back up, and touch 1 and bounce back down, turn, and then back up through 4. And there's a sketch of our graph without using the calculator. Number 13, our degree. This first one counts as 3, and then the next one is 4. So that's degree of 4, which is even. Leading coefficient is a 1, which is positive. It's going to have this shape to it. Now our x-intercepts are going to be at negative 2, 0, and positive 4, 0. Now the first one is repeated 3 times. Now, odd multiplicity, it goes through. So here's my negative 2, and here's my 4. So what's going to happen, it's going to go through, but you're going to see it kind of down. It's going to do a little bit of a turn through it, and then bounce back up through the 4. And there is our graph. And then number 14, the degree. Count them up, that's 2, and another 2, so the degree is 4, which is even. And the leading coefficient is a negative 1. So because it's even with a leading coefficient that's negative, it's going to be going down like that. It's fall left, fall right. Now my x-intercepts are at negative 3, 0, and positive 3, 0. And they're both repeated twice. They have an even multiplicity. Here's my negative 3, and here's my positive 3. So because of that even multiplicity, it bounces at the x-intercept. It doesn't go through. So it makes that. So to meet this shape, it's got to go up, bounce back down at negative 3, turn, go back up, and bounce back down at positive 3. So that's the basic shape of this polynomial with those intercepts showing. So that's a rough sketch of the graph. That is all I have for this section. I will see you again in the next video. Thank you.